So your text talks about, and not very well, some terms like tablespace and index and some other various terms. So a tablespace is effectively a location that holds data files. And basically what that does, that separates the physical location of data from the logical location of data, and that logical location of data is in memory, and occasionally that information in memory, those tables in memory will be written back to that physical location in the table space. So this website, by the way, is through oracle.com, and there's actually quite a bit of good information through Oracle. I don't know if any of you have ever worked with Oracle databases. I've worked with them in the past. Not a big fan, but they're they're pretty effective. The text talks about the physical file and the table spaces and the like on pages 219 to 20, and then how those files are organized. So take a look at that, and it gives you a general understanding of how the files are going to be organized according to this text. Now, depending on the operating system and the database management system you're using, those organizations can be different. And also on page at the bottom of 220, it talks about the file organizations and some factors for selecting different file organization. These are just a few, and be familiar with those. There are certainly others to consider as well. Now, some of the types of file organizations that we'll cover in this text, and these are pretty important to understand. They're sequential file organization, indexed, and hashed. And we'll take a look at how these work. This is a sequential file organization, and the records of the file are stored sequentially, and in this case it's by the primary key field values. So, excuse me, when you are searching for a specific value within a file like this, for instance, when you're looking for flyers, it will start at the top of that sequential file and seek all the way down until it finds the value you're looking for. Now, if the table is sorted, then any change to that table, whether it's an insert or delete, requires a resort of that table. If the table is not sorted, then the search time is the number of records divided by 2. So it could be pretty extensive. And now your text also talks about indexes. So on page 221 it talks about indexed file organizations, and I don't think it explains it very well, but basically what an index does, so every table is automatically indexed on the primary key. What an index does, it creates another data structure that creates an index on another set of attributes, or on one column or a number of columns in that table in the database to form a new index, in addition to the one that is already created on the primary key. So in looking for specific records in that table, you can use those alternate indexes to look up that data. So again, the text really doesn't explain that very well, but let's take a look at how that works. And so, for instance, if this has a tree type structure on the index file organization, and we're searching again for flyers, it goes to F and it automatically goes down because that's the first item in that index, or the first value in that index, and goes down to the next part of that structure. It goes through B, D, and F, and then it goes down and finds flyers and does that relatively quickly. Now, of course, the average search time in a structure like this is going to depend on the depth of the tree. And probably the fastest of the file organizations is going to be the hashed file organization. These are pretty cool how these work. They have an algorithm that is used to be compared against a value that is transcribed from the primary key, so that hash will point directly to the address of a specific record. It's pretty cool how those work. The book goes into a little bit of detail on that, so take a look at that and let me know if you have any questions about it. And this section also talks about joins, and now you're going to see this a lot when you get into database development and even database administration. And effectively what this does, this takes attributes from two or more tables and puts them together into another structure. So these in the joined index is for common non-key columns. So if you take a look at the customer table and the store table, they both have an attribute called city, and you'll notice that that the values in those locations are the same. So if you remember back a three chapters ago, we talked about domains and how domains, a domain is a specific set of values that can be entered into that attribute. So as we can see, this city attribute has a specific domain, which is a list of city names. So we take the attributes from both of these relations and join them into a new data structure that has that common value, and it has the row ID and the row IDs from both the store and the customer relations. And likewise for the for ordering and customer, it takes the customer number foreign key and the customer number primary key and joins those two together into a new data structure, and again uses the row ID from customer and order and uses those in the same data structure. And finally, on page 226 of your text, there table 5-3 has a list of factors that can be used to determine the file organizations and the benefits of each of those file organizations. So take a look at that and kind of get familiar with the pros and cons of either of those. Now, your text also talks about briefly some file clustering and when the file clustering can be used. On page 229, it also talks about when to use indexes and some rules to follow on that. So take a look through those, and that's about all that I have for the course material this week. There's not a lot of new concepts. It's mostly just information kind of building on the concepts that we've already covered. So read through that chapter, and when you finish watching this video, if you have any questions or if I've missed anything obvious, please let me know, and we'll talk about it in the questions area in the discussion.